Column chromatography. Chromatography means color writing. It is the new physical technique of separation, identification, and purification of compounds of a mixture. It is used in many areas of study, particularly in chemistry, biology, and medicine. Pigments, amino acid, vitamins, polymers, etc. can be separated by using chromatography technique.
Basics of chromatography. Mobile base or carrier. Solvent moving through the column. Stationary phase or absorbent. Substance that stays fixed inside the column. Eluent. Fluid entering the column. Eluate. Fluid exiting the column. Elution. The process of washing out a compound column using suitable solvent. Analyte. Mixture whose individual components have to be separated and analyzed.
Column chromatography. Principle. The components of a mixture are separated depending upon extent of adsorption on the stationary phase and the rate at which the component is carried by the mobile phase.
Column chromatography is one of the most useful methods for the separation and purification of both solids and liquids. This is a solid-liquid technique in which the stationary phase is a solid and mobile phase is a liquid. The usual adsorbents employed in column chromatography are silica, alumina, calcium carbonate, calcium phosphate, magnesia, starch, etc. Selection of solvent is based on the nature of both the solvent and the adsorbent.
The rate at which the components of a mixture are separated depends on the activity or polarity of the adsorbent and polarity of the solvent. If the activity of the adsorbent is very high and polarity of the solvent is very low, then the separation is very slow but gives a good separation. On the other hand, if the activity of the adsorbent is low and polarity of the solvent is high, the separation is rapid but gives only a poor separation. That is, the components separated are not 100% pure. For example, when silica gel, an adsorbent with high polarity, is used as adsorbent, we should start eluting with a solvent like hexane having low polarity for good separation. We can see that in the first step, the mobile phase along with the mixture that needs to be separated is introduced from the top of the column. The movement of the individual components of the mixture is at different rates. In the third figure, we can see that the components with lower adsorption and affinity to the stationary phase travel faster when compared to greater adsorption and affinity with the stationary phase. The components that move fast are removed first, whereas the components that move slowly are eluted out last.
Procedure of column chromatography. The adsorbent is packed in a cylindrical tube and is plugged at the bottom by a piece of glass wool or porous disc. The mixture is separated, is dissolved in a suitable solvent, introduced to the top of the column, and is allowed to pass through the column. As the mixture moves down through the column, the components are adsorbed at different regions, depending on the ability for adsorption. The component with the greater adsorption power will be adsorbed at the top, and the other will be adsorbed at the bottom. The different components can be desorbed and collected separately by adding more solvent at the top, and this process is known as elution. The process of dissolving out of the components from the adsorbent is called elution, and the solvent is called eluent. The weakly adsorbed component will be eluted more rapidly than the other. The different fractions are collected separately. The purity of each fraction is monitored using TLC. Like fractions are clubbed. Distillation or evaporation of the solvent from different fractions gives the pure components.
Applications. Column chromatography is best suited to separate organic compounds from plant materials, in separation of compounds after organic synthesis to obtain desired molecules, to separate or purify natural compound mixtures like alkaloids, glycosides, etc. Column chromatography is used for large scale separation and purification of pharmaceuticals.